exception handling. I guess most of you know why we have exceptions. That's because we don't like error codes. If you have error codes, then whenever you consume an API, you need to understand what all those error codes are. That's horrible, right? So of course we have exceptions instead. Now that means it's the implementer's responsibility to handle the failures or to raise the right events if something is not right. So you throw error, right? Just like you have in any other language. It's the same. It's the same reasons we do this, right? So all is good. In X++, you don't have to catch exceptions. If an exception is thrown that's not caught, the error message will just surface to the user. And that's fine. It will not be like an unhandled exception of sorts, so that's perfectly fine. We don't have to catch exceptions. We can if we like, but we don't have to. But if you decide to catch it, then you need to pay attention in the next half hour because there are some pitfalls you need to be aware of. But you don't have to. If you catch it, you basically write catch and then the type error. So here you will notice that the exception is an enum. So it's not like in other languages where it's a class and you can define your own exception types. It's an enum. We have very, very few values in that enum, like 20, something like that. There's a predefined set of exceptions. From an application perspective, we typically use the one called error, and then you can write a string. So you throw an error. That's what we say. You write throw error, basically like I had on in this example, throw error, and then a string about what was wrong. That's how we do it. Okay. So far, so good. So what happens inside when you write this is that it will call a method that will call infolog.add. Infolog is this message sender, right? So as soon as you throw, it will actually put that message in the center, in the message center. It's not rendered on the screen yet, but it will as soon as the logic stops processing. And this one will eventually return exception, which is an enum. So basically, this throw error becomes this. So it's adding an error. This is just an icon we want to say. So this is important, and then it's text, and then it's throwing the enum. So it's basically two things that's happening behind the scenes. Normally, you're just throwing a class, but now we're adding something to a message center, and we're throwing. Throwing will, of course, abort execution, and you need to have someone catching it at some point. And if no one, the platform will catch it and just show the message. Right. So the next line, if there's something here after the throw, will not be hit because we are throwing, just like you would expect. But you will have left something on the Infolog. So X++, it's the enum, the exception, and then the message. And this is what the Infolog used to look like. Now it's something on the side of it. But whatever, the message comes up. Okay. So suppose you do this. What do you think will show up in the Oops. You get this very confusing thing, right? Because you will get both. That's not really intuitive, but this is how it works. So to get the expected result, you will call a method called infolog.line, which will tell you how many lines are in the Infolog when I'm being called. Then when you catch, you say clear everything that happened in between here, and then add my message. If you just call Infolog clear without a parameter, it will clear everything, but then it might actually clear something you didn't want to clear. Right? So you need to have this Infolog line. So you will see this pattern many, many places. You need to capture this up front, which is kind of annoying. You need to do stuff that's exception related before you even get to the exception. One of those things I would love to change, but we can't. So this pattern is the right way of doing it. So if some logic ran before this, you will not clear out any message that came from that thing. You will only clear out what came from your try block. Okay. So I did not update the screenshot, but there's like 20, and here's some of them. There's update config, there's update config not resolved, and there are a few more. There's a transient SQL error. So you can catch each of these if you want. From the application side, we typically use info warning and error. The only one we're throwing would be the error. But you can catch a deadlock or concern by 0 if you like. So when you write applications, you should use the right severity. info, we're not throwing, but there's actually an exception type called info. We use that to give the user some information, something completed, stuff like that. Then we have warnings, which typically will be, hey, this field is mandatory, you must remember to fill it in. It's like something that the user can fix themselves. We're not throwing them either. And then there's a recoverable situations. Here we throw an error. If you see someone throwing a warning, I would call that a mistake, and you should throw an error instead. The only difference is really how you catch it and what icon we show to the user. There's also a method called check failed, which is a variant of a warning. It's basically calling warning and then returning false. So we can write logic like that, OK equals check false, and then we return false because OK becomes false. So typically, if you have validation methods, that's how we do it. So we just, if something's wrong, we call OK equals check false, and then just false. This is some pattern we decided to use. It's a little bit more complicated because when we are running all this logic, it can be very deep, and you can be processing a lot of records in a batch. And if you're processing, say, orders, an order has a header, then it has lots of lines. The next order has a header, a lot of lines. If you just throw an error deep down, or perhaps a warning saying, hey, something is not right here, how would the user know what context you're in? So you don't want to embed all that context on all your error messages because perhaps it's thrown by the platform who has no idea what you're doing. So the way we solve this is by this set prefix method. So you will see that in there, which is basically creating a call stack of sorts from an application context. So in this case, we're saying set prefix my logic from the top header. Then inside here, we say, again, set prefix with I, then you have all the numbers. Then we have something here writing out if it's even or uneven. And then you would represent this. So basically, the set prefix will override itself as long as you are on the same level in the method. You can have as many as deep as you like. And that's a way to create like a context of what's going on from an application perspective. So it's good practice inside a batch operation when you have a while select. You put in some information about what it is you're processing. Some more info about set prefix, not super important, right? But if you have two identical prefixes, they will be collapsed. And if there's just one error message being shown to the user, we are not including all the context, then it will just be on the top of the form, but then they can click show details and get it all, stuff like that. Not a catch all, so you can do this if you just want to catch everything. At some point, we had to write all of this, and then some new exception type came in, and we updated all the logic and tell all our partners to do the same. That wasn't nice, so that got fixed. Transactions. This is where it really becomes complicated. Now, what's most important? Data consistency, or what people would expect when they write code? We decided data consistency is most important. So consider this code. We have a try-catch block, and we're catching everything. Inside here, we're starting a transaction. TTS begin, TTS commit. We're throwing from within the transaction. Who will catch this? This guy or this guy? Logically, it would be the first one. That's what we expect in our languages. But if we allowed the first one to catch it, we would also say this guy needs to make sure that everything that happens so far in the transaction gets reverted somehow or compensated, including what partners wrote in that update statement that they have no control over. Disaster happening downstream. Right? So what we decided, and this is perhaps the most important lessons for today, is if you throw inside a transaction, that transaction is aborted, everything is rolled back, nothing is committed to the database, and the first guy that will catch it is the first catch statement outside the transaction. This is what happens. So you cannot catch an exception inside a transaction, with a few exceptions I'll get to, but basically, no, you cannot. This was okay, mostly we just had regular X++ code. But then in came CLR.NET, all of this. Here there are APIs that throws an exception if you try to pass an integer and a string to an integer and it cannot, then it might throw an exception, which will end up rolling back your entire transaction, even though you have a catch because, hey, I know it might not be as strict. So here you need to use the try-get versions of those APIs to avoid exceptions. Sometimes they're not there, which is super annoying, right? But if an exception is thrown inside a transaction, we are rolling it back. We do not dare allow the code to continue because we know that would be data corruption. Committed data corruption takes us an eternity to unravel afterwards. And so we rather roll back. We rather not use those APIs that exist and find an alternative, even though our code could have looked better. So transactions are rolled back. So TTS abort is another keyword. We typically do not use it in code. We would rather throw an exception because that will roll back the transaction, and you cannot catch anything inside a transaction. So deadlocks. Here we are talking about retries. So suppose a deadlock happens. A deadlock is something the database will throw if you have a log and an object someone else has needs that record, but they hold a different log, and then you try to get a log on them. So basically you have like a deadlock situation, none of you can move forward. Then the database will decide one of you is victimized, one of the threads will be victimized, they will throw a deadlock exception. We can catch deadlock and we can do a retry. This will basically just move the next instruction pointer up to the first statement inside the try block, just like you would expect. The transaction has been rolled back, so we're just starting all over again, right? So again, nothing bad happened. This thing will actually leave some message on Infolog about a deadlock. So this is not how to write it. I'll show you how to do it, but basically you can retry. And so retry is the keyword in X++. Now look at this code, right? This is a common pitfall here. So we have a while select of my table, give me everything today. Then we call a method increment I. And we say if I is more than some constant, we call cleanup something. And a deadlock. Can any of you tell me the problem with this code? So I is declared up here, and it will keep the value it had when the deadlock occurred, and then when you retry, I will be 47, whatever. Keep that value. So one fix would be to declare I inside the while loop, or inside the try loop, basically. That would solve it. So the problem is retry goes here. The fix would be to somehow make sure I gets the proper value again. This can look similar in a scenario like this, but if you have like multiple levels of calls, it becomes harder. The best trick you can do is to have clean code. So basically everything inside the try block is just one method called somewhere else, because then you know there's no state or anything else that can leak. So have single lines in there, then that problem doesn't occur. So this is what I'm leading up to. Can we even see it all? I think we're missing a little bit. Okay, but let's walk through. This is how code is supposed to look in the batch scenario. So if you write a batch class, which is something that's supposed to run in the background, do some processing. Your processing happens inside the do stuff method. You have a try-catch block. You have your transaction begin and commit. So happy part is all of this just completes. We're out here. Everything is great. There are two exceptions that can be caught inside a transaction. One is an update conflict, and one is a duplicate key exception. These two are supposed to help us solve rollback situations, because sometimes we can actually recover from these. We cannot recover from them in a scenario like this, where you're just running a whole lot of things. But sometimes, I'll show you that pattern on the next page. If you have a small update segment just doing one thing, then you can recover from it if there's an update conflict or a duplicate key exception. But in situations like this, you cannot recover from it. So inside here, we have two blocks, and they pretty much look the same. The first line here is saying if application transaction level is different from 0. What does this mean? It means that we are still inside a transaction. How can we be inside a transaction here? Well, someone else could be calling our code. There could be someone else out here that's left all of this inside a transaction. And now suddenly we are being called here inside our logic, trying to catch this. And if we call retry here, we're just retrying a little bit of it. So that's very dangerous. So instead we say, hey, I'm still inside a transaction. I don't dare touch this. Let me just throw the update conflict, and then the next guy out there can figure it out. So that's what this first line is doing. It's the same with the duplicate key exception. The next line is saying, hey, how many times have I been retrying? Because we don't want to retry infinitely, because that's just bad. So if we reach the retry number, which is defined in this macro, to 5, if we tried 5 times, still not working, we throw update conflict not recovered exception, which is a different exception type that cannot be catched inside a transaction. It will just roll back the entire thing, show a message to the user. But in cases where we are the outermost loop and we haven't retried too many times before, then we just call retry and do it again. And then the logic will run once more. Same for duplicate key exceptions. Just want to make sure that what we have here at the very end, basically we're missing one line which says something bad happened, try again later. Basically, we're adding some error message here. In the catch here, I'm also having an application.tts level different from 0. But we should never get here because you can only catch these 2 inside a transaction. So you don't need these lines. In many cases, we do not have this. It's not truly necessary, but just to be on the safe side. So this pattern you will see in lots of places. There are small variants about this, but basically this is what it's doing. We do not have what you call nested transactions in SQL. So that if we could roll back just part of the transaction, that would solve. But we just have a SQL only knows about transaction begin and commit from when we use. You can have multiple levels of TTS begin and commit, but the SQL database will not know. And when you reach the final commit, basically it's a stack. So when you reach 0 again, it will be committed to the database. So why do we allow to catch exceptions inside a transaction at all? And this is for concurrency reasons, really. And here's an example. So suppose you have a table called my table and you want to implement a find or create kind of method. Basically looking up something, it could be like an inventory dimension we talked about before, like one unique size, color, something like that. It doesn't really matter who is creating it. Give it to me if it exists. If it doesn't exist, then create it. That's basically the idea. Now, if it doesn't exist, there's a chance that 2 threads at the same time are coming in, both doing find, basically doing the lookup. None of them finds it. Both of them decides to create it. One of them will succeed, the other one will get a duplicate key exception. We don't want to roll the entire transaction back because we don't care who created it. So here we have logic that says, okay, let's retry here, throw again if we cannot recover. Then we'll clear out the Infolog in case we can recover, but we don't want to show anything. We're then flushing all caches. That depends on the caching type you have, but otherwise, if it's caching that there was nothing, then there's no good retry because it will still not find anything because we want to read what the other guy created meanwhile. Then we call retry, which will go in here, do a find, and now it will see what the other guy created, and it will just return that because now it exists. So this is like the common use pattern where we'll get concurrency. There's nothing worse than running an update statement for 2 hours and then rolling back on something trivial like this. Inventory dimension is a very good example where we do just this. So this is the pattern. Similar exists for update conflicts. It could be that you're updating something. It doesn't really matter who set a value to false or 1 or something like that. Then you can recover that. But the whole key is that you understand what's happening in here, because as soon as you call retry, you're responsible for everything that happened in there are being rolled back. So this needs to be as confined as possible. It is private or something like that, so no one else can have added logic on this that you do not control. But that's the whole purpose of this, and this is a pattern where it makes sense. So now we're talking about making the Infolog messages more useful. So when you parameters, the first one is a string that goes to the user of the message, which is great. And then it has a link, a hyperlink to a help topic. That thing is not supported anymore. So regardless of what it says, parameter number 2 is just not used. It used to be like you can say help, give me more information. So the reason why we don't use that anymore is because it's really, really slow for us to add proper help, because it's a product change. Product changes take half a year to get out. If some users keep hitting the same errors over and over again, we want to respond faster than releasing a product. So what we have instead is what we call in-app help. And here, the system, if some error message occurs, this is a new screenshot, someone click canceled, and an error comes up. Reservations cannot be removed since there's work created which relies on these reservations. Like this error message comes up and no one can figure out what it is. They keep calling our support. What do we do? Like we could log a bug, go and write a help, and all of it takes half a year to get out. But what we can do instead is that we can publish troubleshooting documents, which the form here automatically will know about. So when this error message occurs, then it will find issues where this is described and show this to the user, regardless of what version they're on. And you can get these out within a day. Before I said there are 3 parameters. So this is number 3, and that one still works. That's an action, right? So we would like to throw a message or present a message, and then you can click on it and something will happen. Right, so in this case, there's an edit button here that's showing up in the new UI. I think you need to right click, but basically something can happen. So for example, you need to set up parameter XYZ. It's really convenient if there's a button that will take you to that parameter you haven't set up. Lots of different ways you can do this. You can open a form with a query. Basically, it will position itself to the right record. It can jump to the right column and field, stuff like that. And the logic looks something like this. You create and choose info action _ menu function. Menu function is how we start stuff in X++, and you declare a new one of these. So it's this guy, equals product parameter I want to open. That's a form. And then you just pass that as a third parameter. Then when this error message happens, the user can click it and be on their way. Then we help. We don't do that too much, but we can actually now recommend us doing it. There's a big page on our learning site, which is basically walking through pretty much everything I said here. So if there's something that's not clear, you want to see more examples, and that's the place to go. But exception handling is where most people are struggling, and it is complicated. As you start debugging through and suddenly it's being caught someplace where you don't expect, it's because there are transactions involved. That's everything I have for today.